into this. We left off here. Now, up to this point, we had talked about the future value of a single dollar amount, or the future value of a lump sum. And so we went through some examples of the graduation example of, if you're given, I think it was $15,000, how much will you have in 20 years, 30 years, 40 years, 50 years, etc. We also went through and calculated how much it would cost for your children to go to college. And again, we use that same technique, future value of a lump sum. Now, I did want to say to you, to those of you that were looking at that number at like $82,000 per year, going, wow, that's a lot of money. How am I going to afford to send my kids to college? The great thing about time value of money is, if you look at the $82,000 per year, you think that's a lot of money. There's no way I'm going to be able to come up with that much money when my child goes to school in 25 years. But if you know the cost and you start early, I don't mean when your kid is 16. I mean start when they're born, and you open up something like a 529 plan, which is a college savings plan, then you can use time value of money to your advantage and let your investments work for you over that 18-year period from when your child is born until they start college. And you can have probably most, if not all of the money without really sacrificing just a lot. Because again, you can put in a small amount per month and it will grow to a larger future value when it's time for your child to start school. Okay, and so we can look at that a little bit later. But again, most people just, they just don't want to know. So how much is it going to cost your kid to go to school? Most of your friends, if you ask them, they'll say, I just don't want to know. I don't want to think about it. Well, you have to think about it. If you think about paying for your child's college education when they're 16 or 17 years old, unless you're fairly wealthy, you're going to be in trouble. And so 529 plans, really easy to start. And the great thing about a 529 plan is any earnings that the money you put in the plan make, so any return that it has, that is tax-free as long as you spend it on education-related items such as tuition, living expenses, books, even computers and things like that. So it's tax-free. So it grows tax-free. So that's a really, really nice benefit to that plan. All right, now, we've talked about lump sums. Let's talk about annuities. Earlier, we gave the definition of an annuity. We said it's a series of payments or cash flows of equal dollar amount spaced at equal time periods. So there has to be more than one. They have to be equally spaced, and they have to be equal in dollar amount. And we're going to talk about two different types. One is an ordinary annuity, also called a deferred annuity. With an ordinary annuity, we assume the cash flows occur at the end of the time period. So the end of the month, end of the year, end of whatever time period we're dealing with. The other type is called an annuity due. And with an annuity due, we assume that the cash flows occur at the beginning of each time period. So the beginning of the month, the beginning of the week, whatever the situation may be. And if we draw a timeline and show an annuity, this is what it would look like. This is a 3-year ordinary annuity of $400. And so what this is showing is $400 is being deposited into an account at the end of each year for 3 years. So for example, this is our starting point, time period 0. So the end of this year is also the beginning of time period 1. So the end of the period, end of the first period. The end of the second period, another 400 is put in, and the end of the third period, another 400 is put in. So, how much money have we put in total of our own funds? 400 per year times 3 years, $1,200. Okay? But what this shows us is that at the end of year 3, we would have $1,261 if we earned a 5% interest rate or 5% rate of return, and the difference between the $1,200 and the $1,261 is our interest or our return. Okay? Now, if you wanted to calculate the future value of this 3-year annuity, we could do it simply one period at a time, learning what we used with the future value of a lump sum. So we would just calculate what is the future value of this $400 deposited at 5% for 2 periods, because this is the time period we're dealing with. What is the future value of this 400 deposited for 1 period, and what is essentially the last $400 put in is assumed to be put in and taken out basically simultaneously, so it doesn't earn any interest. So that's why it's just $400. So we could do that, but it will be a little time consuming, especially if we were calculating the future value of a 20 or 30 or 40 year time period. Having to do that one at a time, it's a little tedious. So we could also use an equation. This is the equation. It gets a little messier when it comes to annuities, so we're not going to even use this. I just wanted to show it to you. There is an equation out there. The easiest way, by far, is to use your financial calculator. And so, in using your financial calculator, and by the way, I've got some up here, if you need to borrow one, there's 3 up here. These would be our inputs for the 3-period $400 annuity earning 5%. Now, notice the only difference, because we have an N, we have an I/Y, which we had earlier. The only difference is, instead of entering a present value with an annuity, you enter a payment amount. So the payment is $400 per year. So we can skip the other items, put in an N, an I/Y, and a payment. And it says here you don't have to make the payment negative as long as you realize that the solution is actually not a negative dollar amount. So based on this, let's see. Okay, so let me get out of this. Okay, so this is where we left off. I think this was the cost of your child going to college. So let me get out of this. I'm going to clear out. Then I'm going to go through my clear function. Very important, because now we're changing the type of problems that we're working. So it's really important to go through this. So once I'm showing zeros, I'm going to press my second button and then clear time value of money. And then the second button again and clear work. Now, one thing that I want to point out that I see some students doing is when you push the second key, sometimes I see you just sitting there just pushing it multiple times and then clicking time value of money. So you sit here and you go like this, and then you press clear time value of money. Well, the thing is, you'll notice when I press the second key, it shows up here. That tells me I am accessing what is above these keys. If I happen to press the second key again, it goes away. So if I press this, I'm pressing the future value key. So if you just sit here and press this button several times and then go to clear time value of money, you may or may not access the second key function. It's just basically you've got a 50-50 chance. So just press it one time, okay? So here we go. Second, clear time value of money. Second, clear work. All right. Now here's my inputs. Doesn't matter what order. So I press 3 and press my N key. 5, I/Y, and 400. Now press my payment key. Once I've got my 3 inputs in, I want to compute. Press my compute key, top left-hand corner, and the future value key. And so what this shows me is the future value of these 3 $400 deposits is $1,261, which matches what we saw earlier with the timeline. So did everybody come up with the $1,261? What about my TI 84 users and 87s and 89s? Have you come up with this, figured out how to do this? Anybody using the graphing calculator? You have? Okay. Anybody who can't do it? We've got some professional down here. If you would, either you go to them or you come to her. Nice pink T-shirt right here, and let her show you how to do it. You can have the floor if you want it. Or you can do that. Okay. Just whoever knows how to do it. You can just spread the information as you learn. Everyone with the BA2 plus, you're getting the right answer? All right. All right, so let's work an example. This is a very realistic example. It says you just graduated from college, you started your first professional job, and typically what happens is you go to work for a company that offers a 401k plan. A 401k plan is simply a plan where money is taken out of your check before taxes are taken out. It's invested, and then when you take the money out, after age 59 and a half, you have to be 59 and a half or older to take it out without a penalty. Then when you take the money out, then it is taxed. And the reason for that is you're supposedly going to be in a lower tax bracket when you retire because you're making less money than when you were working. Okay? So you go to work. The first day or second day, you're filling out all of your forms, and they say, we offer a 401k plan. Do you want to participate? And you're thinking, 401k plan, I remember something from my finance class about that. It was a really rainy day, and I think he said it was good, so yes, I will participate. And if you remember that much, I'm happy, okay? So you say yes. And with your trusty financial calculator, you can go through and calculate some what-if scenarios of how much money would I have if I start investing, especially at a young age. It's critically important for you to understand that investing for retirement, the earlier you start, the better off you are. Okay? Don't put it off 5 years. Don't put it off 10 years. Don't put it off 20 years. You start as soon as you can. I promise you will thank me for that multiple times when you're older. Okay? Now, the thing we need to know is we need 3 inputs. Now, notice here, and I've already made this smaller, but notice here, we're assuming you're going to get paid monthly. So we're going to change our calculator to 12 payments per year. And we'll go through that process of why we're doing that in just a minute. But we need some inputs first, so let me bring this up, and hopefully it's working. Okay. You all work in you're majoring in different areas. You're going to have different starting salaries. But just give me some realistic starting salaries in your area when you graduate. What are some realistic starting salaries? How much? 60,000. Okay, what else? 80,000? Okay. 50,000? What else? I know all of you don't start at 50 or 60 or 80. 45, and some are going to be starting less than that. Okay? 36,000, 35,000, 30,000. Sometimes you just have to take what you can get. So let's say, for example, that we're going to start out with a fairly low amount, although for a lot of you, I'd have been really happy to start, making this amount. Let's say you make $36,000. Now, I'll tell you what, I'll give you a pay raise. You're making $42,000 per year. $42,000. And if you're not going to make that much, you can, basically change it to whatever you're going to make. So, you're going to make $42,000. Now, we're going to take the $42,000 and we're going to divide it by 12 months in a year. So that means you're going to make $3,500 per month. And then, just to keep the math simple, we're going to assume that you start out saving 10% of what you make. Okay? So 10%. So 10% of $3,500 means you will deposit $350 per month into your 401k plan. So your payment, let's see, just make sure everybody equals 350. All right, so your payment is going to be 350. We need an N and we need an I/Y. Now, N is going to be the number of monthly deposits that you make. And so I'm assuming that when you graduate, most of you are going to have it, you're going to work at least 30 years. And we can look at longer time periods, but we'll start with 30. And so if we, now, when you change to 12 payments per year, what you have to do is you have to take the number of years and multiply it by 12. So 30 years times 12, if I can get it to right, 12 equals 360 monthly deposits of $350. And the last thing we need to know is what is the I/Y? What is our rate of return that we're earning? And again, it depends on your risk tolerance. If you've got 30 years, I would invest fairly aggressively, and so I think we used 8% in our last example, and I think that's probably a pretty fair rate of return if you invest fairly aggressively in the stock market over 30 years. So we can use 8%. And we're looking for the future value. Now, keep in mind, we want to change the payment per year to 12. Okay, so 350, 360, and 8%. So I'm going to bring up my calculator. And all right, so I'm going to hit my clear button to zeros. Then I'm going to go through my second clear time value of money, second clear work. Now I'm ready for my input. So my first input was $350. So 350, well, wait a minute. I've got to make a change first. I've got to change my payments per year, which is right above the I/Y. So if I press my second key and my I/Y, it's going to show that I was set on, I'm currently set on one payment per year. I want to change to 12. So I'll put in 12. Then press the enter key to lock it in. If you don't press the enter key, it's going to go back to 1. Now I can press my clear button. Now I previously cleared out my input, so I'm ready to go. So I'll put in $350 as my payment. This is a $350 annuity. I'll put in $360 and press my N. That's my number of $350 deposits. And 8 is the I/Y. And what I want to do is that I want to compute, top left-hand corner, future value. Do what? Oh, that's a good point. I'll remind me of that in just a minute, okay? Okay, so you put in $350 per month for 360 months. I don't know how much money that is. You can do the math on that. 350 times 360, whatever it is. But you have, after 30 years, $521, almost $522,000. So $500,000 for putting in $350 per month. Now, keep in mind, this is after 30 years. And the great thing about your calculator is you can say, okay, you know, you're probably, I'm going to tell you right now, you're probably not going to retire after 30 years. You might, but most of you probably won't. 40 years is more realistic. Now, 40 years is going to be 40 times 12 months per year, 480 payments. So N would be 480. So if we leave the same dollar amount, same rate of return, but put in 480 as our N and compute the future value, After 40 years, you will be in your early 60s and you will be a millionaire. Just by depositing $350 per month. Now, let me explain a couple of things to you here. First of all, somebody mentioned this doesn't include a company match. And typically, with a 401k plan, companies are different, but they would typically match a certain percentage of your deposit up to whatever their cutoff point is. So sometimes they will match it 1-for-1 up to 6%, or sometimes they might match it 1-for-1 up to 3% or whatever. So let's say that they put an extra 3% of your pay, or 4 or 5%. Imagine how large this number would be. So it's going to get bigger. And in this 40-year example that we used, how many pay raises did we factor in? None. You started at $42,000 per year. 40 years later, in our example, you were still making $42,000 per year. Now, I'm looking at it, looks like some pretty intelligent people to me. So I'm assuming your pay is going to go from 42 to 52 to 72 to 92 to 122,000 plus per year over 40 years. And if you keep saving 10% of that, imagine what the future value would look like when you're ready to retire and travel or do whatever you want to do. You're going to have a lot of money saved up. Now, I talked earlier in the semester about a lot of money won't necessarily make you a happy person, but it's a pretty good feeling if you've got a big chunk of money set aside to help pay for your retirement. And if you're thinking, well, you know, there's Social Security, so why should I have to save for my retirement? Well, Social Security may or may not be here when you retire. And if you think you're going to have just a fabulous retirement based only on Social Security, I'll just go ahead and tell you right now, you're wrong. I see people just on Social Security who didn't have, and I'll go ahead and call it a privilege, the privilege of somebody telling them about this. So they didn't know if I start at 20 years old or 22 or 25 saving for retirement, even a little bit, $100 per month, $200 per month, whatever, it's going to grow over 40 or 50 years into a huge future value because of compounding. Okay? Now, this was 40 years. I said most of you are going to work 50 years. So if we did that, that would be 600 payments. And you're ready to retire. Well, hang on. I messed up. Let me go back. 350 in 8 interest per year, 600. So this is 50 years. Wait a minute, what did I do? I messed up again. 600 in 350 payment 8 I/Y compute future value. All right. So now, 50 years, $350 per month, you've got $2.7 million saved up. This is not an unrealistic number. You're, in your early 70s. This is, again, something that is, it's just crucially important that you understand. Because if you just wait 5 years to start, what happens is a lot of people, when they graduate, they're thinking, I've been suffering for 4 or 5 years in college, doing without. I need things. I need a new car. I need some nice clothes. I need a better apartment, or I want to buy a house, or I want to start a family, or whatever. But what I'm telling you is, that's fine. There's nothing wrong with all of that. But if you can learn to live on 90% of what you make and save 10%, and you can keep doing that, once you start, you get used to it. And you don't notice that 10% missing and it's going into this account. Now, we started with $350 per month. This is before taxes. If you take taxes out of this, you would take home, let's say you decided this is crazy, you're not interested in this. So the $350 after tax would turn into about, let's see, 30, 35, 70. It ended up being about $225 per month, roughly. So that's what you would take home, $225 per month. Let's say 200, it's easier to work with. Divide that per week, that's $50 per week. Take home if you decided not to do this. What can you do with $50 per week? You could go to, you and one other person could go to a fairly inexpensive, really inexpensive dinner and a movie and split a popcorn and a drink for $50. So basically, look at it like you're giving up a cheap dinner and a movie per week for your retirement. And if you do give up that movie and that cheap dinner per week, you would have $2.7 million in an account waiting for you to spend on whatever you want to spend it on. You can go to all the movies you want with $2.7 million. You can actually have popcorn for both people. You don't have to share it. Okay? See a hand go up somewhere? You can take it out without a penalty after age 59 and a half. Okay? For a 401k plan, you can't. With IRA plans, if you go with what's called a Roth IRA, then you can take it out without a penalty. But a Roth IRA is put in after taxes. A traditional IRA is put in before taxes. That is true. It really depends on your age and your tax bracket. But with a traditional IRA, it works something like a 401k. It's before tax. So you get a tax benefit from that. With a Roth IRA, it's put in after tax. Now, let's just say, for example, the way this 401k is supposed to work, we said, is you're going to be in a lower tax bracket when you retire. Let's say you've got $2.7 million saved up, and you can invest this money. Let's hope that interest rates go up just a little bit, and you can put this money, all of it, you can invest it in United States government bonds, and you earn a 5% interest rate, about the safest investment you can. So you've retired, you take this money, you put it in bonds, and you earn 5%. What is 5% of 2.8? 5% of $2.8 million. I'm asking you this question. $2.8 million, 5%, $140,000. Thank you. So you're making $140,000 just on the interest. The principal is not declining at all. So $140,000, and you're doing nothing. If you're still working, how much were you making? In our example, $42,000 for working 40 or 50 hours per week. So with this example, you're making about 3.5 times as much retired as you were working full time, which means you would be in a higher tax bracket, which means you would have to pay a higher rate of income tax. But the thing about that is, nobody likes paying taxes, but if you're in a higher tax bracket, especially in retirement, it means you've done something right. And if it comes down to the choice between me being in a higher tax bracket versus me trying to live off just Social Security by itself, I'll take the higher tax bracket any time. Because I've seen people trying to live off Social Security. When I was in banking, I was loaning money. I'd have older people in their 70s and 80s, and they were too old or too sick to work, and they hadn't planned for retirement. They were just getting a Social Security check, and they would come in and want to borrow just a few $100s towards the end of the month so they could pay their electric bill or their gas bill to keep the heat on, or so they could go grocery shopping, just so they could get through to the end of the month when their next Social Security check would show up. That's a really, really sad situation to see. You don't want to be in that situation. And you don't have to be. Nobody in here, everybody in here, I don't care what you're doing, if you're working, you should be able to retire in your mid to late 60s with at least $1 million saved up. Everybody in here. Now, you may think, well, that's a long time from now. $1 million in 30 or 40 years won't be what $1 million is today. And that's true, because the cost of living increases. But again, keep in mind, we didn't factor in pay increases. And so if your pay could just keep up with the cost of living increase, you would essentially have the same as $1 million today would equal whatever amount you have saved up in 30 or 40 years. I don't know what cost of living is going to do. I don't know what interest rates are going to do. But I can tell you that if you don't start saving at all, $1 million, no matter what the cost of living increase is, what inflation is, will buy you a lot more in 30 or 40 years than $0 will if you decide to let somebody else worry about it. Okay, so future value of an annuity. Everybody getting these numbers? Is this making sense? Okay, that's a good question. What happens when you switch companies? So you have a 401k plan with one company and you want to change employers. And a lot of you will do that. Essentially, you have three options. You can either leave it with your employer that you're leaving, and they would just, typically, they'll let you do that, and they'll just keep managing it, and it's there. You can switch it, you can transfer it to your new employer if they have a 401k plan. Now, the key is you don't want to touch the money. So they will transfer it from your old employer, they will do the paperwork, or your new employer will actually do the paperwork, send it to your old employer, the money will be transferred, and you don't see it, you don't touch it. Your new employer is now managing it in your 401k plan there. Your third option is you can transfer it from your old employer into an IRA, an individual retirement account, and it depends. Typically, you would transfer it into a traditional IRA, which again is before tax. Unless you want to pay tax on the money, then you could transfer it into a Roth IRA. But you've got those three choices, and probably the last two are the better. If I'm leaving a company, I don't know what's happening there, so I'd rather either have it with my new company or have it in an IRA that I control. Okay, very good question. Other questions? All right. And now, what we just looked at was the future value of an ordinary annuity, where we made our deposits at the end of each time period. But we also said we can have the future value of an annuity due, where the deposits are made at the beginning of the time period. So this is what you see here on the screen. This is our $400 annuity that we've already seen. We make the deposit 3 times. But notice each deposit, instead of occurring at the end of each period, now each deposit is occurring at the beginning of each time period. So the beginning of time period 1, the beginning of time period 2, and the beginning of time period 3. And also notice the future value with our last annuity, then the ordinary annuity was $1261. The future value of the annuity due is $1324.05. So it's larger. So can somebody tell me why the future value of an annuity due is larger than the future value of an ordinary annuity? Because what? Okay, because you're putting the payment in one period sooner. And so you're putting each of these deposits in one period sooner. So essentially you're earning an additional period of interest with each deposit. Okay? So you should have down somewhere that the future value of an annuity due will always be larger than the future value of an ordinary annuity. All else equal. And this is your equation for an annuity due. Notice the only difference is from the last one, the 1 plus R. This is the additional period of interest that we were talking about. And then for your financial calculator, we work the problem just the same. The only difference is, notice we change to beginning of period payments. It's hard to see, but that's what this actually says. Change of beginning period payments. And so, let's do this. Let's calculate the future value of this 3-period, $400 annuity due at 5% interest. Now, I'm taking you back and forth on this, and I want you to notice, first of all, how many times per year are these $400 deposits made? Not for this one. For this one, how many times per year are we making this $400 deposit? There's a timeline. 1 time per year. Okay? So 1 payment per year. We had changed our calculator to 12 payments per year. So now we have to change back to 1 payment per year. And I'm doing this on purpose because I want you to get used to, as you read different problems, I need to change it to 1 payment per year or 12 payments per year, because on the test, it's not going to tell you change to 1, change to 12, change to 1, change to 12. You have to recognize that. Okay? So to do this, I'm first going to press my second key and my I/Y key. I'm set on 12. I want to change to 1, so press the 1 key and then the Enter key. Now I'm going to press my clear button. And now, once I clear back the zeros, I'm going to go through my clear sequence. Second, clear time value of money. Second, clear work. Now, with an annuity due, and you will recognize it because it will say something like beginning. Payments are made at the beginning of the year. Deposits are made at the beginning of each time period, something like that. So once I see that, I'm going to change to beginning of period payments. So to do that, notice right above the payment key are the letters BGN. So if I press my second key and my payment key, notice I'm currently set to end of period payments, which is where I want to be 95% of the time. But you see the word set at the top of the screen? The set key is your toggle switch to toggle back and forth between beginning and end of period payments. The set key is found right above the Enter key. So now if I press my second key and the Enter key, it will toggle my calculator over to beginning of period payments. And then if I press my clear button, bottom left-hand corner, go back to zeros, but notice I have the letters BGN at the top of the screen to remind me I have changed to beginning of period payments. And if I'm going to work an end of period payment problem, I need to change back. Okay? So now, once we've done this, we'll just put our information in. 3 is our end. 5, I/Y, 400 payment, and I want to compute the future value. 1,324.05, which matches what we have here. So did everybody come up with 1324.05? Did you come up with it? Okay. Okay, but what about my graphing calculator users? Right answer? Anybody need some help? She's got it figured out down here. Got it? Okay, anybody else? My BA2 plus users? Right answers? Okay. So you can see that with this calculator, you just have to practice with this. You just have to work problems, work different types of problems, because you're just going to be going back and forth all the time. But if you understand this, I promise you, it will make your life so much easier, and also make your test grade a lot better too. All right, so let's, okay. So that's future value of an annuity, future value of an annuity due. This is the future value of a mixed stream of cash flows. So these are cash flows that are different dollar amounts, but there's more than one. So we've got $400, $300, and $250 deposited into an account earning 5%, and we want to know what is the future value. Basically, the only choice you have here, well, actually, the most basic choice you have is to calculate the future value of each of these cash flows one at a time and then add them up. So the first one, 400, you're putting it in here. So you're putting it in for 2 periods. So N is 2. 5% interest. You would calculate these as the future value of a lump sum. So $400 deposited for 2 periods at 5%. What is the future value? $300 deposited for 1 time period at 5%. What is the future value? And then the last deposit, $250, again, we're considering it's put in and taken out simultaneously. We don't earn any interest, so it is just equal to $250. We add these 3 together. The future value is $1,006. That's the future value of a mixed stream of cash flow. And we'll come back to that a little bit later, okay? All right, now, present value. We've talked about future value to this point. We're going to now switch to, we've taken money forward in time. We have so much money now, we want to know what is it worth in the future. With present value, we're going to use the process of discounting. We're going to take a future cash flow amount and determine what is it worth today. Now, future value, we typically start with that because it's, for most people, it's a little easier to understand. I put money in an account now, it earns interest, I have more later. But actually, present value is a really useful tool when it comes to the business world. For example, if we're trying to value a business, we use present value. If we're trying to value a share of stock, we use present value. If we're trying to value a bond, we use present value. So what we're doing here, we have $935 to be received in 3 years. We've got a 10% discount rate, and we want to know in today's dollars, what is it worth? So we're taking the $935 back 3 time periods at a 10% discount rate, and the present value would be $702.48. So with future value, if you have a positive interest rate, the future value is always going to be larger than the present value. With present value, if you have a positive discount rate, the present value is always going to be smaller than the future value. Everybody follow me? Future value gets larger, present value gets smaller. And this is our formula. We use this one down here, the bottom one. It's the same thing, it's a little bit simpler. Present value is equal to future value divided by 1 plus R. R is the discount rate or the interest rate raised to the nth power. Also, I want to point out one thing to you. In some finance books, to represent interest rate, instead of using R, some authors will use the letter I, so lowercase I, to represent interest rate. Some will use a K, the letter K, to represent interest rate. Some will use an uppercase R or an uppercase I or an uppercase K. The reason I'm telling you this is it doesn't matter what the notation is. It means the same thing. So if you saw this formula and it said 1 plus I raised to the nth power, it's the same thing. So don't look at it and go, whoa, wait, I haven't looked at that one. Mine said 1 plus R. I'm not sure what this 1 plus I thing is. It means that it works the same way. So this is the formula. And we could plug numbers into the formula if you wanted to. This is using your financial calculator. So it's the same thing, basically. But instead of solving for future value, we enter a future value and we solve for present value. So this was the 935 that we had on our timeline a couple of slides earlier. A time period of 3 and an R of 10%. So if I bring this up on my calculator, so let's say I'm here. What do I need to do first with my calculator? Okay, I could go through my clear process if I wanted to. That's okay. That's good. What else do I need to do? Okay, notice it's still set at the beginning. I need to change back to end of period payments. So to do that, it works the same way, same steps. Second, BGN. Second, enter. Change back to end of period payments. If I hit my clear button, then you'll notice the letters BGN are gone at the top of the screen. Now I've cleared my inputs out earlier. Now if I want to, again, you'll just get used to this. Now, let me make sure you're going back and showing zeros before you start your clear process. That's really important. So then I can just go through this just out of habit. And then I'll put my information in here. 3 is my N. 10 is my interest per year. And 935 is my future value. And now I want to compute, I press my compute key, the present value, PV. The present value should be 702.48 after rounding. So essentially, if you have a 10% required return on your investments, you're indifferent between having $702.48 now or $935 3 years from now. It doesn't matter to you. They're the same dollar amount at a 10% rate of return. Okay, so here is an example. Let's work through this really quickly. Just to make sure that you are understanding this. Again, this may or may not be realistic, but we can take a look at it and see what the difference is. It says you're going to receive $100,000 in an inheritance when you turn 30. So let's say you have a relative, they pass away, they want to leave you some money, $100,000, but they're thinking, this person, they're kind of young, they don't make the best decisions right now. And I'm not talking about all of you, just my hypothetical person. They don't make the best decisions, so I don't think it's a good idea to give this person $100,000 right now, so I'm going to make them wait until they're 30 years old. By then, hopefully, they will be more mature, they will be more responsible, and then they can have the money. So this is not uncommon. This is a fairly, a lot of times this happens with inheritances. The problem is you don't want to wait until you're 30. You want the money right now. And we're assuming you're 21 years old. Okay? So it's going to be 9 years until you can get your hands on the $100,000. So you have seen, some of you probably seen, there are a lot of companies out there that will buy future cash flows. J.G. Wentworth is one of them. They have these crazy commercials that you've probably seen. And so you think, okay, I'm going to call J.G. Wentworth and sell them this future cash flow. And you can do that. So you pick up the phone, you call them, and you're thinking, okay, I know we've talked about this in finance some, and they've got to make a return on their money, otherwise they wouldn't buy the cash flow. So you're thinking a 6% rate of return is fair. Okay, so we can calculate the present value of this $100,000 cash flow in 9 years at a 6% discount rate. So I'm going to put in 100,000 as my future value. 9 is my N, and 6% is my I/Y. And I want to compute the present value. And so at a 6% discount rate, you would get a check for $59,189.85. And in 9 years, J.G. Wentworth would get your $100,000. So that's at the 6% discount rate. So you're thinking, that's not $100,000, but I would take it. Okay? Now, the company buying your future cash flow, they're probably not going to think 6% is a fair rate of return, because there's some risk involved. Plus, typically, if people are having to sell future cash flows, not always, but a lot of times they're in a desperate situation. And so they don't care how much money they get, but they just want some money. And so this company, and I'm not going to bring it back up, but it may assume 30% is a better rate of return. And so if we calculate the present value of this $100,000 9 years into the future, so what is it worth today, at a 30% discount rate, we just change the I/Y, so I'll put in 30, I/Y, compute present value. And at a 30% discount rate, you would get a check for $9,429. And in 9 years, they would get your $100,000 inheritance. So you can see as the discount rate increases, the present value gets smaller. And again, you may think, well, there's nobody in their right mind who would take $9,000 now instead of waiting 9 years for $100,000. But a lot of times this is not an inheritance. This is something like you've been injured at work and you've got a settlement coming from your employer, from an insurance company. And if you're behind on your house payment or your car payment, or you need to put food on the table, $9,000 right now, it's not $100,000 in 9 years, but you can buy food with it. You can keep your house from being foreclosed on with it. And so people actually will take this money because they don't have a choice. And a lot of these companies know that, and so they, well, I guess I'll say just take advantage of people. Okay. So is this, everybody come up with the right answers here? Present value. And again, this is a kind of a, probably an extraordinary example, but I wanted you to see that the larger the discount rate, the smaller the present value. And this actually was kind of a real life example. And you can, this, you've got a present value of an annuity, so it works the same way. This is what it looks like. And again, we're taking money back in time. So the payment occurs at the end of the period, and we're taking it back at a 5% discount rate. This is what your formula would look like. This is how we would work it on the calculator. So a $400 ordinary annuity discounted at 5% for 3 periods. And so to do this, I would go through the clear process. Then I would put in my 400 as my payment. 5 I/Y and 3 in, and compute the present value. So the present value, it was $1,200, but the present value at a 5% discount rate is $1,089.29. And with annuity due, it's basically the same thing. You just change to beginning of period payments. Put your payment in I/Y, compute present value. You do it the same way as we did the future value of an annuity due when we have beginning of period payments. And that is probably a pretty good place to stop.